Before I introduce the next set of projects related to instructional support and the role that technology can play in supporting a teacher's efforts instructionally, I just want to acknowledge that my heart really goes out to anybody who's just adversely affected by the aftermath of the hurricane and the tremendous amount of precipitation that fell and all the problems associated with that, especially in areas of North Carolina that are so close to Radford, and even places closer than North Carolina to Radford. I have spent many a long weekend in Asheville, North Carolina. It's a place that I frequent a lot. I love the music scene, the food scene. I attend the Lake Eden Arts Festival. I stay in Black Mountain, and it's just, I love that area, and my heart goes out to all of those people. And if you have anybody that you love who's been negatively impacted, I hope for a speedy recovery, and that, you know, as a society we can get together and help those people who are affected as much as we can. So what a way to start this week. But I'm going to start this next couple of weeks introducing it by asking you a question related to your cell phone use. So have you ever gotten a text from somebody and you weren't exactly sure what they meant by their response? Either there might have been something that you were reading into it in terms of a tone, you know, like something was all caps and you didn't think it needed to be, or something, or they respond to something that you ask and it's something kind of vague, like here's one that I remember somewhat recently. So I asked a colleague of mine I texted them and asked, hey, are you going to so-and-so's house on Friday after work? And all I got in response was 3 question marks. And I saw those 3 question marks and I just immediately thought, oh no, what does that mean? I waited for some follow-up to it, and I didn't really get it. My first thought was they were saying, what are you talking about? What's going on Friday after work? Nobody told me, you know, something like that. Like I thought, oh no, I was invited to something and they weren't, and now I feel stupid. I hoped it wasn't that. So I did something that I'm sure a lot of people who have partners do, and I asked my wife, I showed it to her and I said, well, what do you think this means? She's way more intuitive than I am about such things. And I also asked, like, how should I follow up with that? So what I was doing with my wife, by asking her to interpret what she thought those question marks meant, was I was asking her to triangulate some data for me. So what I wanted to know was, what did the person who sent the text, what did they mean by that? What was the meaning? I'm trying to infer the likely meaning of it. So I could try to infer based on my own thoughts, my own experiences, and all of that. I could, but then I can also ask somebody else who I know is very intuitive, and I could try to see how her response matches up with mine, and then I might be able to have a more accurate kind of guess or inference as to what the question marks meant. So that's called triangulating the data. And the reason why I'm bringing this up is because I was thinking about what you're going to be experiencing in the next couple weeks. And I was thinking about how much throughout my life as a student, how much I ended up hating math. And And I can tell you right now, as somebody who's studied education for a good part of my adult life, I can tell you that the reason why I hated math is because it wasn't taught to me very well. And the reason why I know that is because when I finally did have it taught to me very well, I had one of those aha moments, you know, like, oh my gosh, math isn't this thing that I thought it was, and that I've been sold, or this thing that I've been forced to try, and, you know, it's a game that I don't want to play, and the rules, I don't care enough about the game to even try to make sense of the rules, and all of that. So, and I was thinking about triangulation because even though I had really what I think was some pretty bad math instruction in my life, I did absolutely love trigonometry, and I loved it because, first of all, it to me it was pretty concrete. You know, we were learning about math associated with triangles. You know, and the magic of the relationship between the sides of a triangle and the angle that the sides make. And again, even though I think I had some pretty poor instruction, when I got to college and I started taking physics classes that were very abstract, one of the things that really helped me in those classes was realizing that trigonometry was a really important sort of set of skills conceptually that could help me understand a lot about some of the basic physics that I was learning. Still not taught to me very well. But then when I got to be a graduate student, I was a graduate student, and one of the classes I had to take was inferential statistics. And I was pretty intimidated by it because when I got the textbook for it, I opened it up and, oh man, there were a lot of equations. It was even worse than a physics textbook. And there was so much abstraction in there. But luckily, I had a really good teacher. And one of the things that we did, actually, one of the first things we did is the teacher came in and he brought in a air popcorn popper, and he brought in 3 different kinds of popcorn kernels, and we had a discussion at first, which was, what are some characteristics that define to us a good type of popcorn? And of course, there were characteristics like the flavor, you know, and how crunchy it was when it was popped. But another important thing is how much of the kernels actually popped, given, you know, when you're preparing it. And so we said, well, let's find out whether or not there's which of these 3 brands of popcorn kernels might be best, based on how many actually pop in a given session. And so we went through the process, which was kind of cool because it was very scientific and experimental, but we went through the process of randomly selecting a set number of kernels. I believe it was 500 per sample, and we randomly selected them from the bag, and we used the same machine to pop, which was an air popper. And we put the samples in, and we turned on the machine, and we ran it for the same amount of time until its cycle was up for each of the different batches, and we counted the number of kernels that weren't popped. That was our data point, you know, the number of kernels that didn't pop. We let the machine cool adequately. We had a thermometer and let it cool adequately before we put in the next type. And we ran this experiment 5 times, actually, for each of the 3 types. And we recorded the data, a simple data table, right? It was just 5 data points for 3 types of popcorn. And so we had our numbers, and we just looked at the numbers, and it appeared that one of the brands, there were fewer popcorn kernels in that were unpopped for every single trial for this one brand, but our teacher said, well, is it better, like mathematically? None of them were perfect, and just because one had lower numbers in this 5 trials, how do we know that the difference between that brand and the others is genuinely significant, or at least is significantly lower based on what we could tell? So the teacher started to walk us through the math that you would need in order to determine whether or not the difference in that data set, in the data set of the brand that we supposed was better, whether it was the data being unpopped popcorn, whether it was significantly lower than the other two. It was lower. The average was lower. But was it significant, or was that just due to chance? Would it change if we did it 100 times? Well, so we walked through the math, and what was amazing as we walked through the math is at one point, the teacher said, look at this equation. Does it look familiar? And I'm talking about, we were doing things like establishing matrices with the data sets and trying to figure out what the amount of error and things like that. And then we kind of boiled it down to this sort of abstract equation. And there was a long silence about it being familiar. And I recognized it as looking a little bit what I thought was like the Pythagorean theorem. And I said, that looks to me, that looks like trigonometry, and gold star for this guy. But the teacher did a great thing then. He said, well, why would trigonometry be the kind of math that we would need right now? Like, what are we trying to do, and how is that similar to trigonometry? And the answer was that in trigonometry, one thing you're trying to do is calculate an unknown, given some data that is measuring characteristics of something, but is not the exact thing you're trying to measure. So if you recall in trigonometry, especially right angles, if you know the length of 2 sides of a right triangle, you can calculate the length of the third, even though you didn't measure it. Or if you have the length of one of the sides of a right triangle, and you know one of the angles other than the right angle, then you can calculate all the sides and all the angles. So in other words, you can use this basic mathematical principle to calculate an unknown, something you didn't observe. And what we were trying to calculate was whether or not this the likelihood that the difference between these data sets was significant. It was an unknown, and we could never measure it, but there were things that we could measure, and we had that data. So the fact that this teacher was able to connect, for me, well, for all of us, something that we sort of knew and understood and could recall to this new thing, was a great way to help us learn about inferential statistics and the math that's underneath it. And also, it was a great way to learn, to be introduced to it by actually doing something concrete right in front of us. In this case, it was pretty compelling to try and carry out this exercise where we popped popcorn kernels. Oops, excuse me. So the reason why I'm telling you this is because it relates directly, I think, to what you're being asked to do in the next couple of weeks regarding instructional support, and that is you're being asked to number one, create the beginning of a learning experience that will maximize the effectiveness of the students learning what you want them to learn in the experience. So the beginning, the introduction. So, and you're going to examine ways in which, in little tiny ways that technology can be used to support you creating an effective introduction that would include things like connecting what you want them to learn with something that they already learned, which is what this teacher did, and immersing them in a context that has meaning. And that's what you just finished learning a little bit more about, is how can you contextualize a learning experience so that there's meaning and purpose to having to learn something. That can be established at the beginning of a learning experience, and you can do it in very concrete ways, like this teacher did for statistics for me. You're going to learn about that, and then you're going to learn about how one of the things that most instructional experiences include is the need to present information, concrete information to learners. And there are certain rules that make the presentation of information more effective than others, and you're going to learn a little bit more about that, and then you're going to examine, again, some very simple ways in which you might use technology to help you create or communicate information to learners in an effective way. So, so that's what you're going to be doing, 2 projects in the next couple of weeks, and I hope that you can readily see the value and importance of it. And with that, I'll end. But I'll also I am reminded of one of the things that our inferential statistics teacher presented to us after the popcorn experience had to do with polling data, and that's very, very applicable to life right now. And that is so when you poll a sample of the population and you want to infer the overall sort of attitude or choices or whatever it is you're polling about, and you want to make an inference about what's reflected in the population, as you know, there are scientifically effective ways of doing that involve basic inferential statistics, basic trigonometry, including the generation of errors, of the margin of error, the plus or minus in polls, and all of that is grounded in, again, the fundamentals of inferential statistics. And because you're trying to infer something that you can't measure directly, and so that's a very kind of relevant example of something. And presenting something that's relevant is a very good part of a learning experience. And I don't know if it's too late or not, but if you haven't registered to vote yet, this is a very, very important election coming up in the national election, and I hope that you have had the opportunity to register. I hope you are registered. It means it's very important, particularly in our profession as educators, because you have more than 2 different approaches about what is going to be best for those of us who practice education as well as learners, and really important decisions to be made. But you can't contribute to that unless you register to vote. So I hope that you you're registered. And with that, I present the next 2. Hold on, here's my phone again. Okay, well, I guess it's fitting. I started this introduction with talking about my phone activity, and I'm ending with it. So hope you enjoyed the next 2 projects, and as always, let me know if you have any questions, comments, or concerns.